Okay, we have started AC fundamentals in the last class. Right. We discussed what is frequency, amplitude, and now we will move on to the next topic. This this is a representation for the alternating waveform. Already we discussed in the last class how an AC waveform is generated. So this V is equal to Vm sin theta is a representation for the alternating waveform, right? Vm sin theta here. Or same sin theta we are writing as sin omega t with the angular velocity in terms of angular velocity, right? And now what is omega in terms of frequency? Omega is equal to 2 pi f, or in terms of time period 2 pi by t, 2 pi by t. So the same theta we are writing theta is equal to omega t is equal to 2 pi f or 2 pi by t. Here for these waveform, when you will get the maximum value for the sine wave, when the sine will becomes maximum at 90 degrees, no? Sin 90 is equal to 1, right? What is the magnitude of the waveform then? If you take V is equal to V is equal to Vm sin theta, Vm sin theta. When this waveform, you will get the maximum magnitude here when theta is equal to 90 degrees. When theta is equal to 90, you will get V is equal to Vm. V is equal to Vm. So that we are calling it as a maximum value or peak value or amplitude of the alternating waveform here. Alternating waveform. What is the maximum value then? Maximum value of alternating waveform is nothing but coefficient of the sine of the angle. Coefficient of the sine of the angle. What is the coefficient here? Coefficient of the sine waveform here. This is a coefficient Em. So the maximum value will be is equal to Vm or Em. Em or Em now. Now, how to find the frequency for the same waveform? How to find the frequency for the same waveform? Let us take this waveform. V is equal to 30 sine 314 into t. What is the peak value of this sine waveform here? What is the peak value? That is Vm. Yes, any response from your side? What is the peak value for this waveform? What is the peak value? Already, this is the point number 1. The maximum value or peak value of an alternating voltage is given by the coefficient of the sine term, coefficient of the sine term. Here, this is a coefficient here for the sine term. Here, what is the term? 30, right? 30 is the maximum value here. Maximum value here. Now, for the same waveform, I'm asking you to find the frequency here. What is the frequency of this waveform? How to find the frequency? It is in the form of V is equal to am I audible?
Yes, sir.
Yes, sir.
I'm getting doubt, man. No one is answering, that's why. Okay, this is in the form of V is equal to Vm sin omega t, right? Vm value already we obtained here. Vm is equal to 30. And what is the value of omega? Omega for this curve, it is equal to 314. But we can write omega as 2 pi f is equal to, we are getting 314 here. Now, what is the definition for frequency here? Coefficient of t, right? Coefficient of t divided by 2 pi. Coefficient of t divided by 2 pi. We will get the frequency. This is the definition here. See, the frequency f is given by the coefficient of time, that is small t. Coefficient of time divided by 2 pi. Divided by 2 pi. Now, this is the given waveform. Now, another problem. Now, this is the given waveform. What is the maximum value for this waveform here? What is the maximum value for this waveform? Just what we will check for any given waveform? We will check whether this is in the form of the AC waveform or not. What is the AC waveform representation? V is equal to Vm sin omega t. So whichever the term, that is coefficient of the sine term, that we are considering as the maximum value. Now what is the coefficient here?
Im.
Yes, here coefficient is Im
under root
r square
plus 4.
4.
What is that, sir?
Yes, very good.
4 omega square L square.
Square, very good. Now, what is the frequency here?
2.
Here, from the first one, already you answered. We got the Vm maximum value for this curve. Now, from the second point, what is the frequency?
2 omega by 2 pi.
Frequency is equal to coefficient of t. Coefficient of t is 2 omega.
2 omega by 2 pi.
By 2 pi. Very good. So this is the frequency now. Frequency is equal to W by pi hertz. Right? This is the way to find the maximum value and the frequency for the given AC waveform.
Sir, explain the last one once again, sir.
Just any of the AC waveform, we will compare with the V is equal to Vm sin omega t, right? V is equal to Vm sin omega t. What is Vm? It is a coefficient of the sine term. So here the coefficient of sine term is here coefficient of sine term is this term. So this we are considering as a Vm. That's all. And according to the second point, frequency is the quotient of time small t divided by 2 pi. Quotient of small t. This is the quotient of small t. 2 omega by 2 pi. So you will get W by P. Or in a simpler manner, just you remember AC waveform is a V is equal to Vm sin omega t. Any of the waveform we will compare. What is V? Vm sin omega t. This is a representation for Vm. Instead of W, we are having 2W. This is 2 pi f. Omega is equal to 2 pi f. This is a omega is equal to, we are having 2W here. But what is omega? Omega is equal to 2 pi f. So f is equal to 2W by 2 pi. So this is a way to find the frequency and the Vm. Yes, no. The next topic is the phase. Next topic is the phase. Phase. Here, see the definition for phase. It means that the fraction of the time period, of the alternating current which has elapsed since the current last passed through zero position or the reference. So Just I will explain by taking one example here. So these always zero position will consider as a reference here. So if you ask the phase for this curve, it's starting at the zero position only. So the phase is zero here. The phase is zero here. Now, if we are having the waveform like this, we are having. So the time elapsed, right? The time elapsed from the reference. This is the time elapsed. Let's suppose this is an angle alpha, right? After alpha angle, it is getting started now. After alpha angle, it's getting started. So this is the time elapsed from the reference. The time elapsed from the reference. So what is the phase for this? From the reference 0, it is maintaining an elapsed angle of alpha. So the alpha is called the phase for this waveform. Phase is equal to alpha, right? And whether it is in lagging with the reference wave or leading with the reference wave. Lagging means it is the waveform is started at 0 after some angle of alpha. After some angle of alpha, it's getting started. So if it is a waveform A, now if we take it as waveform B, now waveform B is in lagging with A with A by angle alpha, by angle or some time period, by angle alpha here, right? Now now I will consider one more waveform here. This is waveform C I am considering, waveform C. Now it's maintaining an angle of alpha here, but in the negative side. So the phase is minus alpha here, phase is minus alpha, but the waveform alpha is starting in before with reference to A. A is started here, but C is starting before to A now. C is starting before to A by an angle of alpha. So we will say that C is in leading C is in leading with A by angle alpha, by angle alpha here, right? So here in this figure, A and B, two waveforms we are having, but both are rotating with the same angle here. If A is started at 0, B is also starting at the 0 reference only. So there is no phase difference between them, right? And we are calling A and B are in phase. Both are in phase. Both are in phase now. Now here, if you have taken the reference frame x-axis with the angle, we will represent the phase in terms of the angle. And if we have chosen time on the x-axis, just we will represent the phase in terms of the t, capital T, right?
Sir, please explain once again what is phase.
Okay. Phase is an angle, okay, at which with an elapsed angle, the waveform is getting started from the reference wave. From the reference. Reference means we will take 0, right? Reference we will take 0. If the waveform is starting at 0 itself, we are calling the phase, we are saying that phase is 0. But if it is starting after some time period of t, okay, after some time period of t with respect to the reference, ఇదండి రిఫరెన్స్ ఇది ఇక్కడే స్టార్ట్ అయితే ఫేజ్ అనేది లేదు, 0 దగ్గర స్టార్ట్ అవుతుంది, అంటే ఫేజ్ ఈజ్ ఈక్వల్ టు 0. అదే కొంచెం యాంగిల్ తర్వాత స్టార్ట్ అయింది అనుకోండి, ఇది అంటే ఒక టైం పీరియడ్ తర్వాత స్టార్ట్ అయింది. సో దిస్ టీ ఈ రిఫరెన్స్ నుంచి ఎంత డిలే అయిపోయింది, సో విత్ టైం పీరియడ్ ఆఫ్ టీ ఇట్స్ గెటింగ్ స్టార్టెడ్. ఈ టీని మనం ఫేజ్ అంటున్నాం. ఇంకా ఈ ఎంత అయితే డిలే అయ్యి స్టార్ట్ అవుతుందో రెఫరెన్స్ నుంచి దాన్ని ఫేజ్ అంటున్నాం అంతే.
Yes, sir.
సార్ ఒకసారి బ్యాక్ స్లైడ్ చూపియండి సార్,
ఓకే.
ప్రీవియస్ స్లైడ్. సార్ ఇక్కడ ఎఫ్ అనేది ఒకసారి మళ్ళీ చెప్పండి సార్.
ఇది ఫ్రీక్వెన్సీయా?
ఫ్రీక్వెన్సీ ఒమేగా పై ఎట్లా వచ్చిందని మళ్ళీ చెప్పండి సార్.
అంటే ఈ లాస్ట్ దాంట్లోనా నువ్వు ఫస్ట్ దాంట్లో అడుగుతున్నావు?
లాస్ట్ దాంట్లో.
లాస్ట్ దాంట్లో యాక్చువల్లీ మనకు జనరల్గా కన్సిడర్ చేసేది సైన్ ఒమేగా టీ కదా.
ఎస్ సార్.
మనకు అక్కడ ఒమేగా బదులు 2 ఒమేగా ఇచ్చాడు. వాడు ఏమని
2 ఒమేగా ఇచ్చాడు. అప్పుడు 2 ఒమేగా ఈక్వల్ టు 4 ఒమేగా 4 పై ఎఫ్ అవుతుంది కదా సార్. ఒమేగా ఈక్వల్ టు 2 పై ఎఫ్ అవుతుంది సార్. 2 పై ఎఫ్ కాదు సార్.
అంటే లేదు, లిజన్ కేర్ఫుల్లీ. ఆ 2 ఒమేగాని ఇవ్వని సమ్ ఎక్స్ ఇచ్చాడు అనుకోండి, మనకు సంబంధం లేదు. నేను ఎక్స్ని 2 ఒమేగా అనుకుంటున్నా, రైట్? ఎక్స్, ఈ ఎక్స్ని 2 ఎక్స్ ఇస్ ఈక్వల్ టు 2 ఒమేగా అనుకుంటున్నాం. బట్ మన ప్రొసీజర్ ఏంటి? ఫ్రీక్వెన్సీ ఫైండ్ అవుట్ చేయడానికి ఫ్రీక్వెన్సీ ఈజ్ ఈక్వల్ టు కోఎఫిషియంట్ ఆఫ్ టీ బై 2π, అంతే కదా. వాడు ఏమైనా ఇవ్వండి, మనకు సంబంధం లేదు. బట్ మనం ఫాలో అయ్యేది ఒమేగా ఈజ్ ఈక్వల్ టు 2πf, రైట్? ఎఫ్ ఈజ్ ఈక్వల్ టు, అంటే ఇది ఎప్పుడు
2π బై ఒమేగా అవుతుంది.
వాడు ఒమేగా ఇచ్చినప్పుడు ఇదంతా, ఒమేగా ఇచ్చినప్పుడు ఇదంతా అవుతుంది. ఒమేగా బదులు వాడి ఇక్కడ 2 ఒమేగా ఇచ్చాడు కాబట్టి 2 ఒమేగా కన్సిడర్ చేస్తాం. అక్కడ
2 ఒమేగా కన్సిడర్ చేస్తే 4πf వస్తుంది కదా సార్. అప్పుడు ఒమేగా ఆ ప్రాసెస్ ప్రకారం పోతే ఆన్సర్ వేరు వస్తుంది సార్.
లేదు, ఏం చేసి రాదు చూడు.
అంటే
నేను చెప్తా చూడు, ఇక్కడ ఒమేగా 2 ఉంది అనుకోండి. ఒమేగా 2 ఉన్నప్పుడు ఏమంటాం? కోఎఫిషియంట్ ఆఫ్ టీ బై 2π. ఈ బై 2π ఎందుకు వచ్చింది? అక్కడ ఏదైనా ఉండని మనం ఒమేగా ఈక్వల్ టు 2πf అనుకుంటున్నాం కాబట్టి ఇక్కడ ఒమేగా వాడు ఏదైనా క్వాంటిటీ ఇవ్వండి, కోఎఫిషియంట్ మనం కన్సిడర్ చేసేది. మళ్ళీ ఎఫ్ ఈజ్ ఈక్వల్ టు ఒమేగా బై 2π. ఇక్కడ ఏమవుతుంది?
ఇప్పుడు ఈ ప్రాసెస్ ప్రకారం ఎటు చేసిన ఆన్సర్ రెండు ఒకటే వస్తున్నాయి కదా సార్, 2 ప్రాసెస్ చేస్తే.
అవును. ఎందుకు ఇక్కడ చేంజ్ వస్తుంది చూడు, ఒమేగా బై 2π వస్తుంది ఇక్కడ. ఇక్కడ ఏమవుతుంది? ఇక్కడ ఒమేగా బై π అవుతుంది.
కాదు సార్, ఇక్కడ మీరు ఇప్పుడు 2πf ఈక్వల్ టు ఒమేగా అని చేసినారు కదా సార్. దాని నుంచి మీరు ఎఫ్ కనుక్కున్నా లేదా కోఎఫిషియంట్ ఆఫ్ టీ బై 2π చేసినా రెండు ఆన్సర్ ఒకటే వస్తుంది కదా సార్.
అవును, కోఎఫిషియంట్ ఆఫ్ టీ అది ఎక్కడ నుండి వచ్చింది? మళ్ళీ ఫైనల్ దీని నుండే కదా, స్టార్టింగ్ ఇదే పాయింట్, దీని నుండే ఇది వచ్చింది. ఏం డిఫరెన్స్ ఉంది? ఏం లేదు కదా.
అంటే అక్కడ 2 ఒమేగా ఇచ్చాను కదా సార్.
ఇక్కడ ఒమేగా బదులు వాడు 2 ఒమేగా వేసి మనం 2 ఒమేగా తీసుకుంటాం అంతే. సో ఎక్స్ తీసుకున్నాడు, x ఇస్తే x/2π అంతే, y ఇచ్చాడు y/2π, అక్కడ సంబంధం లేదు ఇంకా మనకి.
అంటే ఒమేగా ఈక్వల్ టు 2πf ప్రాసెస్ ప్రకారం చేసిన ఆన్సర్ వేరే వస్తుంది కదా సార్, అది అడుగుతున్నా సార్.
ఇది ఒకసారి చెప్పు ఏమొస్తుంది చెప్పు.
అంటే ఒమేగా ఈక్వల్ టు 2πf కదండి సార్.
అవును,
2 ఒమేగా అంటే 4πf వస్తుంది కదా సార్.
మనము రిఫరెన్స్ తీసుకునేది ఏంటి ఎప్పుడైనా సైన్ వేవ్ v = Vm sin ωt, రైట్. ఇప్పుడు ఇక్కడ కంపేర్ చేస్తే కోషంట్ ఆఫ్ టీ అనేది ఇక్కడ ఒమేగా అవుతుంది. మనకి ఇక్కడ ఒమేగా బదులు 2 ఒమేగా ఇచ్చాడు. సేమ్ ప్రాసెస్ ఒమేగా = ఇక్కడ 2π తీసుకుంటున్నాం, రైట్. అక్కడ 2 ఒమేగా బదులు తీసుకోము, మనం దీని నుంచి డెరివేషన్ అనేది స్టార్ట్ చేసినాం. f = W/2π, అది రెఫరెన్స్ గా తీసుకున్నప్పుడు ఈ W is nothing but coefficient of t, coefficient of t by 2π. అదే ఇక్కడ ఫాలో అవుతాం, కోఎఫిషియంట్ ఆఫ్ t అంటే 2W/2π అవుతుంది మళ్ళీ సెకండ్ కేసులో. ఓకేనా? Okay, now what is the phase difference here? Now A, B and C, we are having 3 coils here, right? And we are rotating in the angular frame. Now if A is started at 0 here, A is started at 0. A is started at 0. But here B, after an angle of beta, B is starting rotated here. B is starting rotated here. After an angle of beta, B is started here. So what is the phase difference here? The phase of A is 0, the phase of B is beta, and the difference between the phase is beta minus 0. So we will get the phase difference of beta here between these two waveforms, right? Now these coil C starts rotating with an angle of alpha after B is rotated. After B is rotated, so these angle we are considering as alpha here. Okay, C is started after an angle of alpha here. So the difference between the phase difference between B and C is alpha. But if you take between A and C, what will be the phase difference here between A and C? What is the phase difference between A and C? B is started after an angle of alpha, right? When you compare to A, now C is started after an angle of alpha when you compare with the B here. So here phase difference is B and phase difference is alpha here. So the total phase difference between A and C will be beta plus alpha here, beta plus alpha, alpha plus beta here. So that is the That we are calling it as a phase difference. Now consider three similar singleton coils displaced from each other angles by an angle of alpha and beta and rotating in a uniform magnetic field with the same angular velocity. Right? And the EMFs in these coils do not reach their maximum or zero value simultaneously, but one after the other. ఇప్పుడు ప్రీవియస్ కేసులో ఏం తీసుకున్నాం, A and B are starting at the same point, అంటే సేమ్ జీరో నుండి స్టార్ట్ అవుతుంది, మ్యాక్సిమం కూడా సేమ్ పాయింట్ దగ్గర రీచ్ అవుతుంది. బట్ హియర్ విత్ అన్ యాంగిల్ ఆఫ్ ఆల్ఫా, సో ఏసీ వేవ్ ఫామ్ ఇది తీసుకుంటే ఏ స్టార్ట్ అయింది ఇక్కడ, ఈ వేవ్ ఫామ్ వచ్చింది. బి ఏమవుతుంది, బీటా తర్వాత స్టార్ట్ అవుతుంది. బీటా తర్వాత స్టార్ట్ అవుతే జీరో పాయింట్ ఇది అవుతుంది, మ్యాక్సిమం ఎక్కడ వస్తుంది, ఇక్కడ వస్తుంది. మళ్ళీ జీరో ఎక్కడ వస్తుంది, ఇక్కడ. నెగిటివ్ వేవ్ ఫామ్ ఎక్కడ స్టార్ట్ అవుతుంది, ఇక్కడ. సో దిస్ వేవ్ ఫామ్ వి విల్ గెట్. దిస్ ఇస్ ఫర్ బి. And after beta with an alpha angle, the C is getting started here. So this way we will get the waveform. So the maximum and zero positions will not be same for these three waveforms, right? And if I ask you one question, with reference to B, which is lagging and which is leading? Which waveform is lagging and which waveform is leading? With reference to B, I am asking now. B to compare this, ఏది లీడింగ్ లో ఉంది, ఏది లాగింగ్ లో ఉంది?
C is lagging and A is leading, sir.
Very good. C is in lagging. C is in lagging and A is in leading. Very good. చూడండి ఇక్కడ C అనేది B తర్వాత ఆల్ఫా యాంగిల్ తర్వాత స్టార్ట్ అవుతుంది. A before to B with an angle of beta. So it's in leading with an angle of beta here. Leading with an angle of beta here. Lagging with an angle of alpha. Lagging with an angle of alpha here, right? So this is the concept of phase difference here.
సార్ లాగింగ్ ఇంకా లీడింగ్ అంటే ఏంటి సార్?
లాగింగ్ అంటే వెనుకబడి ఉండడం కదా. ఆ యాంగిల్, ఆ వేవ్ ఫామ్ అనేది కంపేర్ టు అదర్ వేవ్ ఫామ్ వెనుకబడి ఉంటుంది. విత్ ఇక్కడ అంటే ఏ పర్ఫార్మెన్స్ పీస్ పైన వెనుకబడి ఉందని చెప్తాం, ఇంకా యాంగిల్ with an angle of alpha, or if you take time period on the x-axis with a difference of time period, we will consider. Now we will discuss about the concept of RMS value, right? Let's see the definition here. Root mean square. The RMS value of an alternating current, the RMS value of an alternating current is given by this is a definition, by the steady current which when flowing through a given circuit for a given time produces the same heat as produced by the alternating current when flowing through the same circuit for the same time. సింపుల్ లాంగ్వేజ్ లో చెప్తాను చూడండి. కింద సర్క్యూట్స్ ఉన్నాయి కదా రెండు, ఇక్కడ ఒక రెసిస్టర్ కన్సిడర్ చేస్తున్నాను. వన్ రెసిస్టర్ ఐఎమ్ కన్సిడరింగ్ హియర్. If we have given with DC supply here, okay, what happened? Some heat will be generated around the resistor here. This is a heat generated, and heat will be dissipated as a power, as a power. So we are calculating here the power also with the wattmeter. With the wattmeter, we are calculating the power dissipated in the resistor, right? And when you are giving another alternating quantity here, alternating quantity here for the same resistor. So when the same heat will be generated at some point of time, the same heat will be generated, and that value we are calling it as the RMS value here. That value we are calling it as the RMS value here. Here also wattmeter will be considered here for the power measurement, right? See, the steady state current which when flowing through the given circuit and a resistor we are considering for a given time, some 5 minutes of time లో, ఓకే, ఈ రెసిస్టర్ లో DC సప్లై ఇచ్చినప్పుడు ఎంతైతే హీట్ జనరేట్ అవుతుందో, ఓకే, సేమ్ రెసిస్టర్ కి అదే 5 minutes లో ఆల్టర్నేటింగ్ క్వాంటిటీ ఎక్కడైతే సేమ్ హీట్ జనరేట్ అవుతుందో ఆ వాల్యూని RMS వాల్యూ అంటాం ఇక్కడ. ఓకే, the steady state current which when flowing through a given circuit for a given time produces the same heat as produced by the alternating current when flowing through the same circuit for the same time. This is the definition, and we are calling it as RMS and as well as effective or virtual value for the alternating current. Effective value, virtual value, or RMS value for the alternating current. But most of the times we will use RMS value only. So this is the experimental setup for the RMS value. And what is the nature of this curve here? The second curve. It is a sinusoidal waveform, right? This waveform is sinusoidal. And if we take V is equal to Vm sin theta, whenever this theta changes, we are getting the different values here. This is a waveform for 0 to pi angle, only 180 degrees, right? Whenever it is changing, it's getting to maximum, and again it is reaching to 0. So what these values are called now? What these values are called? Overall, we are calling it as a sine waveform, sinusoidal waveform. But these instant of time, at theta is equal to 0, we are getting some value. 30, we are getting some other value. 45, 90, and so on. So these values, we are calling it as the instantaneous values. Instantaneous values. Instantaneous values, right? So these are the positive half cycles, which is a symmetric waveform here. This is a symmetrical, sorry, this is a sinusoidal waveform, and this is a non-sinusoidal waveform. Non-sinusoidal. This is pure sine wave. This is not sine wave, and you may consider some triangular waveform here for any other waveforms, right? And we have two methods for the symmetric waveform, how to calculate the RMS value. For the unsymmetrical waveforms, how to calculate the RMS value. So this is the method for pure sinusoidal, right, and symmetrical. This is the method for pure sinusoidal and for the symmetrical waveform. We are considering an AC waveform. I is equal to Im sin theta. What will be the nature of this waveform? We'll get this waveform. When you substitute the values theta from 0 to 360, we are going to get this waveform. Is it symmetrical or unsymmetrical? whichever the waveform you're getting in the positive cycle, the same waveform you're getting the negative half cycle also. So this is a symmetrical waveform. So this is a way to find the, I will explain how to calculate the RMS value for the symmetrical waveform with this example, right? We are considering I is equal to Im sin theta. What is RMS? In the name itself, we are having root, mean, and square. Root, mean, square value. First, we will start from the square. Start from the square. All the instantaneous values have been considered here. I is the instantaneous value. Instantaneous values have been considered and we are squaring them. We are squaring them. We are squaring them. Now, what is the mean? Let us suppose we are having instantaneous values I1 to I10. I1 to I10 we are having. First, we are squaring all the instantaneous values and we are finding the mean. What is the mean? Average. Sum of them by the total time period. Here the time period we are considering a sine wave. So we are considering the total time period is here 5 and 5. 2 5 we are getting. So I square by 2 5 and square root for this term. Square root for this term. So this is the method to find the RMS value for a symmetrical waveform. For a symmetrical waveform. And here we are substituting I is equal to Im sin theta here. I is equal to Im sin theta here. Right? But how to integrate the sine square term here? We will write sine square is equal to 1 minus cos 2 theta by 2. Sine square is equal to 1 minus cos 2 theta by 2. So just integrate these terms here. Integral of 1, we will get theta here. Integral of cos 2 theta, sin 2 theta by 2. And we're going to substitute the value 0 to 5. These are the limits. These are the limits for all the instantaneous values. 0 to 2 pi, total time period. 2 pi we are considering here. While finding the mean. While finding the mean, we are having the integral term also. So at the end, you are going to get, after substituting these values, Im by root 2 you will get for the sine waveform. What is 1 by root 2? That is 0.707. 0.707. So what is the RMS value? RMS value of an alternating quantity or sinusoidal waveform is 0.707 times of the maximum value, Im. So this is a method to find the RMS value for the symmetrical waveform. Okay, I will stop here. Just give your attendance K6. K6. Respond fastly.
Present, sir.
K7. K7. K8.
Present, sir.
K9.
Present, sir.
K10. Sorry. L0.
Present, sir.
L1.
Present, sir.
L2.
Present, sir.
L3.
Present, sir.
L4. L4.
Present, sir.
L5. L5 absent. Okay. L6.
Yes, sir.
L7.
Present, sir.
L8.
Present, sir.
L9.
Present, sir.
M0.
Present, sir.
M1.
Present, sir.
M2.
Present, sir.
M3.
Present, sir.
M4,
Present, sir.
M5,
Present, sir.
M6,
Present, sir.
M7, M7,
L5 present, sir.
L5 present, huh? Okay. M7, 2,
Present, sir.
3, Q3, Q4, Q3 absent, Q4, Q5,
Present, sir.
Q6,
Sir, present. Actually, I'm listening from Q7 due to current problem.
okay. Q6 is present, huh?
Yes, sir.
7,
Present, sir.
8,
Present, sir.
9,
Present, sir.
R0,
Present, sir.
R1,
Present, sir.
R2, R2, R2 absent, R3,
Present, sir.
R4,
Present, sir.
R5, R4, R5 absent, R6, R7.
Sir, M7 present.
Wait. Let me finish all this.
R7 present.
I am R6, R7
M7.
present.
R7 present.
Okay.
Sir, R4 present.
R2 present. Okay.
Sir,
R4
M7.
present.
M7,
present.
M7 present. N6 present.
K7 present, sir.
Sir, R4 present, sir.
Oh, okay. N8 present. Okay.
Sir, K7 present, sir.
వినబడిందమ్మా ఎన్నిసార్లు చెప్తా ఓకే థ్యాంక్ యూ ఐ విల్ కంటిన్యూ ఇన్ ద నెక్స్ట్ క్లాస్